We're continuing on in Unit 2.5, Pre-Calc Binomial Probabilities Distributions, now expected values. Expected values doesn't have to be with regards to a binomial distribution, but a lot of times it can be, at least for us in what we're doing. But expected value comes up quite a bit because, especially like if you're betting money and you want to see what's your expected value every time you bet, well, we'll show you how that works. So with expected value, what these numbers are, this is a binomial distribution that we just did because we were spinning a spinner and it was a 1/3 chance of landing on a green. And so we did that previously. And so you can look at this if you want, but this is what we worked off of. So we got this distribution from that. Now we want to see what's my expected value. In other words, for every time that I spin 4 times, I want to know what is my expected time that it takes for, or the expected amount of times that I will land on green on average for those 4 times or those 4 spins. I hope you can see that the distribution kind of stacks up right here between 1 and 2. And with that, why it stacks up, well, the numbers just stack up by 1 and 2, but my expected value is going to be very near these 2 values. Probably between 1 and 2, I'm going to guess. It's not going to be out here 3 and 4 because there isn't much probability going on out here. And so the expected value is kind of a weighted average. And so the weight in these areas is based upon the probability. Where am I weighted the most? Right here, right around 1. And so I'm going to be right around 1 for my expected value. So if I want to calculate the weighted average, what I do is I start here at 0. The 0 outcome, I'm going to take this value and multiply it by its probability because that's how much the 0 is weighted. So if I do that, I get 0 times 0.1975. That's the weight of the 0. If I do the 1, I'm going to do the weight of the 1. So it's going to be 0.395062 times 1. And we can continue on in that fashion. So I just take this probability times this number, this probability times this number, this probability times this number, and I'm going to end up with this situation here. And so then my final answer, if I crank all that out, I'm going to get, wow, that's going to be nasty, nasty decimal. What? 4/3. Oh, it came out really nice. Oh, that sometimes happens. So my expected value is 4/3. Well, what does that mean? That means that if I do this experiment over and over again, I would expect to come out between 1 and 2 times landing on green out of the 4 times. So if I repeated a 4 trial experiment over and over and over again, I would expect to come out about 1 1/3 of the times coming up green in each one of those experiments. So if you average those things out, that's what you would get. That's my expected value. Okay, so if we want to change this, no, let me stop for 1 second. If you want to do this on your calculator, I showed you how to put the distribution into F1. If you do that, you don't have to calculate these things one by one if you don't want to. What you can do is go to a home screen and type this in. This would be 0 times that first value. This would be 1 times that second value. Well, it's 1, 2, 2, 3, 3, 4, 4. And so if you do that, plugging it into the binomial, this is the answer that you do get. That's a lot easier than typing in all those decimal places. If you left them as fractions, you could have used those though, but it just makes it a little bit easier. If you like typing into the calculator, go ahead. But this is one shortcut you can use if you put the binomial distribution formula into F1. And here's a picture of the distribution again. Where's my highest probability? Oh, up here. So I expect my number to come in between 1 and 2. And sure enough, it did at 4/3. Okay, so here's the definition. Expected value is the probability weighted average of a discrete set of data. This can be found by this right here. Well, what's X? X is the number of occurrences of an outcome. So it's how many times an outcome occurred, and then you're going to multiply that times its probability. You're going to do that over and over and over again. Really, if you have your distribution chart, you just multiply these outcomes, boom, 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 boom. Add them up. and then you have it. Since we have the probability, that's why the number comes out reasonable. Okay, so let's do one more example here. So this example, in a roulette game, a player may bet on a ball falling into one of 38 numbered cubby holes. A player may bet $1 and then win 36 if their number matches where the ball lands. There's other ways to bet in the game too, but this is one way to do it. And so if you do bet on a number, what is the expected value of betting $1? So what you have to consider now is that you lose $1 as soon as you pay it out. So you have to consider that. And then if you win $36, well, we'll see what happens here. So what are your outcomes? Well, either you win or lose. So when I put this together here, what's happening is that your expected value, how many ways can I lose? Well, 37 out of 38 ways I can lose. How much do you lose? I lose $1 because that's all I'm betting. And then I'm going to add in $35. That's if I win. And then it's multiplied by 1 over 38. So this is my expected value. Now some of you right now are going, well, why isn't this 36? Well, why isn't it 36? Well, you did have to buy the ticket for $1. So when we look at our outcomes here, our outcome would be minus $1. This would be the probability. This would be $35 you win times 1 over 38. Now notice these numbers aren't the 0, 1, 2, 3, 4 that we just used in the previous example in the distribution, but this is a way of saying, okay, what's your outcome? Losing $1. How many ways? That many ways. Winning $35. How many ways? This many ways. And if you put that together, you're going to be losing 0.0526. What does that mean? Well, it means that you'll lose approximately 5 cents every time you play on average. Not terrible. That's kind of cheap entertainment. I'm not encouraging gambling. But you'll lose it because it is a negative value. So every time I bet $1, I'm expecting to lose 5 cents. Now, if many people are playing, now the casinos get that margin back and they win that. And so they like doing that. They are in it for the money. So that's what's happening. Okay, so here's a couple examples of expected value. I hope that this made sense. One is with the binomial. The other one is not with the binomial. And in both cases, you'll be expected to know how to do the expected value of both of those. Thank you very much. Take care. Have a great day.